We are going to use our right triangle trigonometry to help us solve word problems. So the first thing we need to talk about are the angles of elevation and depression. So your angle of elevation is an angle that anytime that you have a horizontal line, so like your line of sight, or maybe even it's, you're just talking about something being on the ground or like a boat being in the water, that would be your horizontal. Anytime that you have to look up from that horizontal, then that angle that you have to look up at is going to be your angle of elevation. So going from the horizontal up, this is my angle of elevation. And then anytime you have to look down, so from the horizontal, and you would have to look down to see something from here down, that would be my angle of depression. So the nice thing about angles of elevation and angles of depression is that they kind of like go along with this property that you may or may not remember from geometry. When you have parallel lines cut by a transversal, the angle, the interior angles, alternate interior angles, like this angle here and this angle here, those two angles are the same as each other. So basically, if you know the angle of depression, so from here down, the angle of depression from one perspective, you also know the angle of elevation from another perspective. So say you were, standing on the ground right here, and maybe you had a friend who was standing up here on the top of a cliff. So for your friend to look down at you, he would be looking down at the same angle that you would be looking up at him. So those two angles are going to be the same as each other. So sometimes when you draw your diagram, your angle of depression will be outside of the triangle that you're working with, but that's okay because you can just make it the angle of elevation in the triangle that you're working with. Okay, so we're going to do a couple examples here. First thing you want to do, of course, always read your word problem. So for this one, we have a power line is connected to the top of a building to the ground 260 meters away from the base of the building. So the first thing you want to do is just draw a little diagram. So for this, I'm going to draw a building. So I'm going to make a rectangle here. Here's my building. And then it says that a power line is connected to the top of a building, connecting the top of a building. So here's the top of the building to the ground. So here's my ground level here. Let's do this. I'm not very good at drawing, so I'm going to use these tools to help me out. So here's my ground. And my power line is connected to the ground somewhere, 260 meters away from the base of the building. So the base of the building is here. The power line is connected here. So my 260 meters is going to be right here, because this is the base of the building and this is where the power line is connected to the ground. At what angle is the wire connected at the building? So your angle of depression, if the wire is 340 meters long, so the wire itself is 340 meters long. What's the angle of depression? Well, the angle of depression, if you think about the horizontal here, your angle of depression is going to be this angle right here. So this is the theta that you're actually looking for. But as you can see, that's kind of outside this triangle. So we're going to make a right triangle out of this. Your theta is here, angle of depression from this perspective. So that means you can go down here and call it theta. And that's your angle of elevation from that perspective. So now you have just this right triangle where you need to find this angle. With respect to this theta right here, we have the adjacent and the hypotenuse. Adjacent hypotenuse, that's a cosine. So you're just going to do a little cosine of theta equals your adjacent, which is 260, over your hypotenuse, which is 340. And then you're just going to go to your calculator. You're going to punch that in your calculator. Cosine inverse of your 260 over 340, or you could reduce that if you want. It doesn't matter. You're going to get the same answer. Okay, and then for all these answers, we're going to go ahead and just round it to 2 decimal places. So punching that in your calculator, you end up with 40.12 degrees. Okay, so our next example is talking about a clothesline is connected from a window on one building to a window in a building across the alley. So the first thing you want to do is just go ahead and draw your two buildings. So maybe we have a building here, we have a building here. So we have a clothesline that's connecting these two buildings. Before you draw that clothesline, though, read the next sentence. The clothesline is 10 yards long with an angle of depression of 17 degrees. So what that means is they're not connected. It's not connected straight across to where it's parallel to the ground. It's kind of slanted a little bit. So if you want to think about a line that's connecting these two buildings, that would be this line here, but it's saying that our clothesline is connected at an angle of depression. So if I put like a few little windows in here, I know you're impressed with my drawing skills. So my clothesline, maybe it's connected to this window here on this building, but then it's connected to this window here in this building. So basically what that does is it makes you a right triangle. So if you take this line here, that's going to be the width of the alley. They tell us that the clothesline is 10 yards long. So here's my 10 here. The angle of depression is going to be right in here. This is my 17 degrees. And then how far apart are the buildings? Well, that's this red line here. You're looking for X. Okay, so again, you just have to decide what trig function you're going to use. So my 17 degrees is supposed to be right in here. 17 degrees. With respect to that, I have adjacent and hypotenuse because this would make your right angle right here. So this is going to be cosine again. So cosine, instead of theta, it's cosine of 17 degrees equals X over 10. So you're just going to go ahead and punch that in your calculator. 10 cosine of 17 equals X. So X equals 9.56 yards. Okay, and then I always want to make sure your answers make sense. This makes sense because the clothesline's 10 yards, but it's on a slant, so it's going to actually be longer than the actual width of the alleyway. So your alley is a little bit shorter, 9.56 yards. Okay, next question, number 3. A sailor is looking at a kite. So, draw a sailor. Just draw a little boat down here. And he's looking at a kite. So we have a kite in the air here. He's looking at a kite at an angle of elevation of 36 degrees. So we know these are all going to make right triangles. So if you want to just go ahead and sketch your triangle in. That's backward. So just draw a right triangle in here. Flip it over. Okay, so your right triangle is going to be from the boat to the kite. Okay, so it says he is looking at the kite at an angle of elevation of 36 degrees. So my 36 degrees angle of elevation is coming from the bottom up. Here's my 36 degrees. And the distance from the boat to the point where the kite is directly overhead is 40 feet. How high is the kite? So the distance from the boat, here's the boat, to the point where the kite is. So if you go from the boat to the kite, we're talking about the hypotenuse here. This is 40 feet. And then how high is the kite? And then you just pick a trig function. So with respect to my 36 degrees, I have opposite and adjacent. Nope, I don't. I have opposite and hypotenuse. So that's a sine. So sine of 36 degrees equals x over 40. And then you're just going to multiply by 40. So punch in your calculator. 40 sine of 36 equals x. And then when you punch out in your calculator, you should get that x equals 23.51. Okay, next question. Simon is standing on the street corner. Simon's eyes are 6 feet off the ground. So we got Simon over here. So if his eyes are 6 feet off the ground, so I know this is 6 feet. He's looking down at a cockroach on a box that is 1 foot off the floor. So we have a little box over here. So this is 1 foot. And then there's a bug on the box. And Simon is looking down at the bug. So if we draw a right triangle out of this, the triangle is actually right here, because you have to take into account that the bug is sitting on a box. So here's my right triangle. So you kind of have to adjust your measurements here. So if his eyes are 6 feet off the ground, but when he looks down at the bug is sitting on a box 1 foot up. That means this is actually only 5 right here. If he's looking downward 40 degrees, so your angle of depression is 40 degrees, so we have that horizontal here. Angle of depression is 40 degrees. That means also the angle of elevation from the bug to Simon is also 40 degrees. Then you just pick a trig function. We want to know how far is he from the cockroach. So this is our x, because directly from him to the cockroach is going to be this side right here. Okay, so this is going to be a tangent because we have our 40 degrees here, we have the opposite, and we're looking for the adjacent. So tangent of 40 is 5 over x. So you're going to multiply both sides by x. And then just go ahead and punch it in your calculator. 5 divided by the tangent of 40. And you should get 5.96 feet. So hopefully that makes sense. And then the last one we're going to do together is this boating problem here. So we have 2 boats that are observed by a parasailer. So if we have a parasailer up here, so here's the parasailer. Okay, so then there are some boats down here. So draw your boats. And then what you're going to do is just go through and read the problem and see where you're going to draw your lines. So 2 boats are observed by a parasailer 75 meters above the lake. So here's our lake. That's the lake. He is 75 meters above the lake. So if we do his height, he's above the lake. Whoops. 75 meters, so you can mark in your 75 here. The angles of depression are 12.5 degrees and 7 degrees. So he sees them at different angles. So if he first looks at the first boat, and then he looks at the second boat, these are two different angles of depression. So the horizontal is going across here. Your angles of depression, I'm going to draw them in two different colors for you, so are 12.5 degrees and 7 degrees. So from here to here, when he's looking at this first boat, this is 7 degrees. But then when he looks at the other boat, he goes from here to here. This is our 12.5 degrees. So you have to set up two different functions here, and then you're going to end up having to subtract because they want to know how far apart are the boats. So if you think about this right here as being your x, what you're looking for, well, this triangle right here, this is not a right triangle. So I can't just go straight for my answer. So what you need to do is you need to think about these as two right triangles. So you want to think about this right triangle right here, and then this big right triangle. Okay, so we can go ahead and switch our angles. We know that they're angles of depression. We're going to go ahead and make them angles of elevation from the boat's perspective so that we can have everything down here in these triangles. So if this right here is 7 degrees, that's going to this boat. That means that this here is also 7 degrees. And if from here down, when he goes to look at this boat, is 12.5, that means that this is also 12.5. Okay, so what you need to do, you're going to think about it as two different triangles. So this would be my x, this could be y, and then you want to think about the length of this whole big triangle as z. Because what you're going to end up having to do is solve the big triangle, find z, and then solve this smaller right triangle and find y, and then your x is just the difference between those two. Okay, so you're going to use tangent for both of them because you have the opposite side and you're looking for the adjacent. So you're going to do tangent of 12.5 equals 75 over y. And then you're going to do tangent of 7 equals 75 over z. Because your 7 degrees is this big right triangle here. Okay, if you punch these in your calculator, your y here, oops, so 75 divided by tangent of 7 should give you, or sorry, 75 divided by tangent of 12 will give you 338.3. And then if you do the tangent of 7, 75 divided by the tangent of 7, then you're going to get 610.83. That's your z. And then in order to find x, x equals z minus y. You subtract those, you get 272.53 meters. I apologize, this lesson was a little long today and things are a little sloppy, but there's those word problems. So on the worksheet that I uploaded today, if you guys could go ahead and do numbers 6, 7, and 8 for today. Try those on your own, and I'll upload the answers here shortly. So all you have to do are numbers 6, 7, and 8 for practice. All right. Let me know if you have questions. Thanks.